All right, everybody, we are live here at the Trottier Observatory. I'm just going to get everybody to do an audio check for me to make sure that they can both hear me and as well as Zena. Zena, do you want to do an audio check for us, please?
Sure. Hello, everyone. I hope everyone's doing well. We have a really clear night tonight, so I'm excited for what we have for you.
And we'll just make sure that I've got
All right, everybody. We are
a hi from both of us. Oh, that's echo. We're going to make sure to turn that off. Sorry about that, everybody.
Get
All right.
everybody to do an audio check for me to make sure that they can both hear me
Oh,
and as well.
sorry. Mute. There we go. Sorry, that's a double on my end. Can everyone hear everybody? Just to make sure everyone heard Zena and myself. Audio sounds good. Okay, perfect. Everyone's going to get a bit of an echo there because I was playing myself through my own feed. I am sorry. So thanks, everyone. Welcome to Starry Nights from the Trottier Observatory. I guess we should call it like Trottier Observatory After Dark or something like that. So something. What do you think? No? I mean, we do have to do it at nighttime. So there you go. Yeah. So welcome to all of you. Thank you for coming out. And of course, also welcome to our moderators in the chat feed. We have Kyle and Indira from the observatory staff. And then we also have Jennifer Kirky, who is joining us as a physics instructor from Douglas College and a member of RASC. So thank you very much, Jennifer, for also joining us to talk about space.
Quiet.
I know. So yeah, again, Zena, if you can get as close to your laptop microphone as you can, that would be great. So we have some exciting news for everybody today, and that I want to share with you. So right now, we're just looking at Vega because I had that set up as a target to make sure that our camera was working. I'll turn the live stack off on that so we can look at it a little bit more brightly. There it is. But I want to show you, we made some upgrades. So we made some modifications to our telescope. And so to give you an idea, I'll open up some photos here, before and after of the telescope. So usually the telescope at the Trottier Observatory looks kind of something like this. And so you're always able to see the structure of the actual, like the front part. I don't know what you call that. There's probably a technical name for it, but like the arms that hold the front part of the telescope together. So you can kind of see right through there. But it also means that the telescope is susceptible to light pollution. So anything that kind of like sneaks in from the side of the telescope. And so the issue is lately, as all of you may know, those who've been participating in Starry Nights over the last couple of weeks, is that there's some new lighting around campus that has been impacting the telescope. And so as a result, what we've done is we have added a shroud to that front part of the telescope. And before we went into dark mode at the observatory, I took a photo from the remote camera so you can see it. So that is the new shroud that is now on the telescope. And as a result of that, it has cut down a lot on the light pollution that we've been experiencing, which means that now we're able to do imaging of fainter objects like nebula or nebulae. Zena and I were trying to figure out what the correct pronunciation was on this earlier. Nebulae. And so we have put this on, and it should help a lot with us when it comes to imaging, which we're pretty excited about. So we've already done some test target shots of fainter objects, and they looked amazing. And so we're excited to have the observatory back in working order. Before, it was like having a Ferrari, but like in a traffic jam. That's what it felt like, trying to image with all the light pollution, because we had this amazing telescope and it was being blurred out by all of the light. So yeah, so I think we're going to get started if everyone is ready. And we're going to get to the nebulae objects later on in the evening. We're going to allow for a little bit of extra darkness. And so to get started, we're going to do a couple bright objects to start with. And then within the next half an hour or so, after we've gone through some of our brighter targets, we'll be able to go to the nebulae, and look at some of them.
Just to put it this way, it's not nebulas.
It's not nebulas. Yeah, that's right. It's one of those other ones. So whatever the correct pronunciation is on that, I'm sure somebody knows. Yeah. So we're looking at Vega. We're actually going to move over to, this is one of my favorite stars, and that we can have a chance to see it during the summer because it's a prominent summer star, and that is the star Antares, which we can find in the constellation, there we go, of Scorpius. So let's head over in that direction.
So who are you this time? Are you Captain Kirk?
What's that? Sorry?
Are you Captain Kirk? Are you playing Captain Kirk?
I mean, Captain Kirk is one of the reasons why I am in space and astronomy. Although I will say later on that once I got older, I think my more of my space dad figure became Captain Picard as a result of Star Trek: The Next Generation coming out. So you can imagine how excited I was when like the Picard series came out and Picard came back to television, which is good. So Zena? I know you're a sci-fi fan. What's your sci-fi of choice? What do you watch?
Other than Star Trek?
Yeah.
Oh man, what have I watched? My brain's not working on it. I'm sorry. I can't think of one right now, but mostly it's like a Star Trek. But then
Yeah.
I've been playing video game more.
Okay, cool.
Like Mass Effect has been.
Oh, that's my favorite.
Yeah. I
Yeah.
love Mass Effect.
Yeah, as a video game trilogy, it's amazing. Yeah, I was actually as you know, I've been working on a film for a while, and one of the people, actually two people in the film, are people that we interviewed that worked on Mass Effect, which is pretty awesome. So there you go. Okay, so we're looking at Antares, the star. So right now, the way we're looking at it is in small scale exposure. So we're looking at it right now at like 875 millisecond exposure. So this is almost like a stop frame movie. Dr. Joanna Wu, who's in the chat feed, had said that astronomers often say nebulae, but keep in mind that we're not linguists. So I guess we could just call it whatever we want. We can call it nebulous, and if people are cringy,
Really? I like Nebula.
that's fine. Yeah, we can do that.
I
Yeah. Now, Antares looks cool like this, but this is, okay, one of the problems with looking at stars this way is that they become such a small point of light that they're flicking around so much. So if I turn down the exposure time on this, you'll notice that it just kind of becomes like a moving sort of dot in the sky. And that's from the motion of the atmosphere. And also Antares is quite low to the horizon right now, so we're looking at it through a lot of light. But it is one of the stars that we've actually been able to image and capture as like a spherical object. So this was taken by the European Southern Observatory, and this is an actual picture of Antares the star. And to my knowledge, there is very few that we're able to see and to actually like image. And one of them is this one, and the other is another is Betelgeuse, and I think that's about it as far as like actual like radii of stars. And so because Antares is so large and part of the sky or in the sky, and its radius is so big because it's close to us that we can actually image it and get a picture of its surface. What I'm going to do, I'm going to actually switch to exposure mode and do some like tiny exposures of Antares because it does look cool as an exposed object. So we're actually do like a quick live stack of it because I find that those look
probably it's bigger than Betelgeuse, I think, or is it smaller? I'm forgetting between the sizes.
That's a good question. I think they're pretty comparable. So actually, some details of it. So Scorpius Antares is part of the constellation of Scorpius, and it's an irregular variable star. So it's considered the heart of the Scorpion. It is a red supergiant, 12 times the sun's mass and 600 times the radius of the sun. Oh, my live stack has reset. We got a bit of a delay on the camera these days because we switched cables, and as a result, it doesn't always want a live stack for me. Here we go. There we go. So let's try again.
Beautiful. So that image you showed, that super red giant.
There we go. And so a cool thing about Antares in the southern part of the sky is that it is it's part of actually like a cluster or a grouping of stars. It's not so much a cluster, but it's called an association. So the Scorpius-Centaurus association, it's called. Scorpius-Centaurus is one of the, well, that was a really big exposure. Probably didn't do it quite that much. Let's bring it down here a little bit. Boop. There we go. 20-second exposure is probably a bit much. Let's do something like 5. There we go. And that association is a group of like massive stars that are moving through that portion of the galaxy that probably all formed together a long time ago. And as a result of those stars moving in that direction and having all formed together, we actually know like about how old that they are. And so Antares is probably not more than like a few million years old. It's kind of like a baby, really, when it comes to stars. There we go. And turn off some of that green. And stars in this region, we've also seen a number of like supernova in this part of the sky. And we think we actually might be flying through part of them. So some of the supernova that happened in this region of the sky where Antares is from, some of the iron, radioactive iron from these explosions are now found in like the Antarctic and in the bottom of the oceans. So the Earth is actually kind of passing through some of the like debris from supernova in this region, which is pretty amazing.
I gotta say, whatever that shroud is doing, it's a major difference.
Yeah, there's not so much like hue and glow and stuff all over the place anymore, which is kind of neat.
Look how beautiful the star looks. It actually looks like a star. You see, it literally has that star shape. Beforehand when we were doing it, it just looked like a circle or a dot.
Or a dot, yeah.
Yeah, this is actually looks like a star.
So the spikes on stars like this too, when you're imaging them, are actually from the way that the telescope is designed. So when you're imaging like telescopes that have a secondary mirror in them, the diffraction, the spike that you see is actually like part of the structure of that mirror in the telescope. So it's only certain types of telescopes that basically are that make that kind of spike on stars, which is sort of fun. So there you go. All right, let's move on from Antares. Oh, actually, one other thing I wanted to mention. You mentioned Star Trek, Xena. So this star is one of the stars that's mentioned in Wrath of Khan. I think I brought this up one of the previous times. Is that Khan says to Captain Kirk that he'll chase him around the Antares maelstrom before he gives him up.
That's why this is one of your favorites. I get it now.
It is, yeah. It's one of those cool. Like, it's one of the stars that's actually mentioned. I know it's mentioned in science fiction, and I love. To give you an idea of what the Antares maelstrom actually looks like, this is part of a star complex called the Rho Ophiuchi Star Cloud Complex, and the star off to the left in that picture is Antares. And so Antares actually has like a giant nebula surrounding it that's basically just like off gassing from the star, like blowing itself out into space, which is pretty cool. So think about that, like when this one giant star. For a while, we thought Antares was like the biggest star that we had ever seen until our telescopes got bigger, and it got outclassed by other stars that are even bigger, which is pretty amazing. 600 times the radius of our sun, Antares. So if you're looking south in the sky in the next couple days, you can always check out Antares, and you can see it. So it's a big bright red star in the southern sky, just low to the horizon in the constellation of Scorpius, and that is Antares. Anti-Mars, antagonist to Mars is what Antares means, because it's red, kind of like Mars in the sky. And there you go.
Why is it Oh, for some reason I thought you meant anti. I was like, why is it anti?
Like a rival to Mars in the sky. All right. Okay. Next. I'm glad you're a fellow Star Trek fan.
I think most our audience are.
There's probably a lot of them out there. Yeah.
Probably.
All right, we're gonna slew to Accurate, which is our next bright target.
No. It's not accurate. Oh, that's how I remember. No, I'm just kidding.
Yeah, how accurate.
Star.
I love it. That's great. Are we being very accurate right now?
If you go live in that solar system where you have that star, everything is super accurate.
Accurate. I love it. Sometimes the telescope is not very accurate, depending on what we're looking at. All right, let's get a brighter exposure here.
Yeah, I can see we're not being accurate enough.
Are we on target? Where are we? Are we still waiting for the dome to move? All right, still waiting for the dome to catch up. There it goes. So for those of you who are coming to the stream for the first time, this software here is called SkyX, and it's what we use to point at the sky, and that's why it's called the sky. And it's super amazing because it has basically the entire night sky programmed into it. And so we can just click on an object, I hit go, and the telescope is kind enough to go and find that object for us. There is the number of RASC members whom we fondly call rascals, who will show up, and hopefully Xena, I'm looking forward to us all being in person again at the observatory. I don't know about you. I'm hoping that we get to do that soon.
I would love to go back in person. I need to see the telescope, you know?
Yeah.
It's the same feeling. It doesn't feel right.
It's not the same. Yeah. I think one of the cool things about doing the streams is that we've been able to connect with people. Like, there are literally people from like around the world that connect now to the telescope, which is really cool. So I think what we're going to do is we're going to be continuing, even once in-person events happen again, we'll still be doing some of the streams online so that some of our friends, hello space friends, that we've made from around the world are able to join up with us. But yeah,
parents, because I'm a high school teacher, they like this, like the online version, like online way of doing it more, because they don't have to commute all the way, because
right,
it's more nighttime event and their kids have curfew and bedtime, so
and all
this
that
works
stuff
better for them in a way.
Yes, exactly. Okay, we're gonna zoom in here. So this is accurate, and so in a way, I'm gonna explain, Xena. Accurate is kind of like my, I don't want to say, I was gonna say revenge target. That sounds silly. This is my spite target to another double star we used to always look at, which was Albireo.
Oh yeah,
because Albireo is cool. I'll grant that, because you have like one star that's like definitively blue and one that's red. But then I found out, to my crushing disappointment, or what that was found out recently, is that Albireo is not a true binary star system. It's a visual binary. Yeah.
Really?
So it's like, apparently those stars don't actually orbit one another at all. Oh my God, that is a giant spider. Sorry, a giant spider just walked past me and on the wall. Sorry, everybody. I don't really like spiders, and one just walked past me. Okay. Anyways, so it turns out that Albireo is not a binary star system. It's like a visual binary. Whereas Accurate is an actual binary. So when Albireo crushed my heart, I was like, okay, I'm going to go and look for a real binary star system. So here is Accurate. It's 20 light years away. And the two stars have a very highly eccentric orbit. So they actually are orbiting one another. And so one star will get as far away as 71 AU, astronomical units, that's the distance between Earth and the Sun, which is about 150 million kilometers, and gets as close as 36 astronomical units. To give that in perspective, Neptune is 30. So this star orbits almost as closely at some point as Neptune does of our own sun. The bright star is a G-type star, so that's about the same type as our sun. Dr. Joanna Wu says that Albireo actually might still be a real binary, but it's a very loose one. I wish Albireo wouldn't keep like teasing me like this. So just saying. Anyways, so these two stars, they orbit each other. They're actually orbiting one another. And if you were on a planet,
very accurate.
What's that? Sorry.
It's an accurate binary system.
They're an accurate binary system. Yeah. The orange star is the other one. It's a K orange dwarf star, class K. So if you remember you may not know, so I'm throwing out letters. I should say what they mean. So we classify stars by letter grade, and they go, oh my goodness, now I'm going to try to remember them in order. I'm not going to remember.
O is the most massive star.
I know there's actually like a rhyme. I remember that.
Of course there is a rhyme.
It's like A, B. Okay, stellar classification letters, because I always remember all the order of them. And I know Professor Howard Trottier taught me a rhyme, and now I forget it. So there's O, which are the hottest and typically the largest. B, A, F, G, K, and M. So G is ours. K and M are usually orange and red dwarfs, so smaller than ours. O's are the biggest. O and B are like usually massive bright blue stars.
Kyle just said it. Oh boy, an F grade killed me.
Thank you. I appreciate that. Thank you, Kyle. I knew it was out there somewhere or existed somewhere. And yeah, so the smaller star that's orbiting is an orange K-class star, and so it's much smaller. And if it were, I had a note here. It said that like it's about 3% the luminosity of the sun, and yeah, it's half the mass basically of the other star. Dimmer. It would shine in the sky with the light of 5 full moons. So if you were on a planet orbiting the bigger star, the smaller star would just kind of look like a very bright moon in the sky, which is kind of cool. I'll do a stack on this one as well, and because I tried that yesterday and it actually looked pretty cool. But I'm gonna change the time on it. Actually, I might leave it the same. Okay, let's see what happens.
You find it interesting that most stars out there are actually binaries, or some sort. They're more than one.
Yeah, it turns out, that our sun is kind of in the minority, right?
Like our solar system is the odd one that has only one star.
Yeah.
In the middle. So maybe that's where life is. We just have to look for those ones that has one star by itself.
Yeah. Okay, so here we go. I'll throw it down. Look at that. Isn't that cool? Look at that. So you can see the two stars there together in the stack. That's very pretty.
That is beautiful. So I'm assuming then if you were to look at this with the binoculars or not, or even with the naked eye, you probably won't see this as, you won't distinguish the binary.
No, yeah, typically I don't think there are any naked eye binaries. I think all the sciencey folk that are in the stream can confirm this or not, but I don't think any binaries would be nearly gravitationally bound and yet close enough that we'd be able to see them with the naked eye. So it's quite difficult sometimes to even distinguish stars that are in systems even with a telescope, never mind to the naked eye. So I think the only one that is considered a visual binary, but I don't think it's an actual binary that you can see is in which is Mizar, which is in the Big Dipper. So some people will say on a clear night, if you can make out Mizar as a visual binary, then you have pretty good seeing conditions or like good eyes in that way, which is one of the stars in the handle of the Big Dipper. And I've really just kind of been killing time. So not killing time, but I've been burning up time with our brighter objects so we can wait for it to get a bit darker so we can get into some of the more exciting, fainter objects, which is going to be nebulas, so we'll see later. But first, we're going to get Zena to talk about some of the star clusters that we had on our list for the evening. So where are we going to?
Let's go to M13.
All right, let's head to M13.
M13. Yay, the great globular cluster, probably the largest one we have in our Milky Way.
I think it's the largest one in the northern hemisphere. I think there's one Omega Centauri, which is one of the globular clusters in the southern hemisphere, is bigger. But I've never had a chance to see it because I haven't really been to the southern hemisphere for a long time.
Oh, that would be nice. They have very beautiful skies. Probably chilly. Probably they have the prettiest ones over there. But yeah, globular cluster. So just from the name, it's a cluster or a collection of thousands of stars. And I hope like with the image that we're gonna get, I'm actually excited, especially now that we have the new tech, or we can block the light pollution. So we can see more of the different colors of stars or different types of stars in the cluster. So I'm excited for that. So usually with globular clusters, they tend to be really old, and they also reflect the age of the universe. So the age of the universe is about 13.8 billion years. So I think the one that we're looking at, so the globular cluster we're going to look at, it's about 11.7 billion years old. So there you go, very close to the age of the universe. Nice. So with globular cluster, because you can tell you can tell their age based on the type of stars that are in there. So if you see more of the red orange stars, so that kind of reflects that these stars are old. I don't know how much you know about the cycles of stars. So you start with like if you're a massive star, then you end up being a blue star, a very hot young blue star, and then that blue star turns into a red giant or a super red giant, and then later on it turns into either a black hole or a neutron star. And that's why, so when we see those red or orange stars, we know that those are considered old stars. And when we see blue stars, and we know that they are young and hot. So we're seeing more and more of the stars. I remember last time when we were trying to look at M13, I wasn't able to see the different colors of the stars. I just saw like one color or one shade. But that could be because of the light pollution, so maybe now this is gonna fix it.
Yes, I have noticed actually. So this is something this is one of my favorite targets. And I put it up last night when I was just kind of fooling around with the telescope and having some fun. And I noticed that even some of these brighter objects with the shroud also look a lot better. And like you were noticing, I was able to pull out more of the color of the individual stars as a result. I think, and you noticed that too when I was showing you the image I took yesterday.
Nice. I'm seeing it already right now.
Yeah, you can see the variation between the blue and the red stars. Yeah.
Nice. So one of the things I was wondering about is that if the globular cluster are so old, why do we see young stars, which are the blue stars. And it turns out that because of the cluster, they're all going towards some sort of a center, because all the stars are gravitating towards each other. Like the force of gravity is making them coming towards the center. And like each star will pull another star, and that's how it goes. And so you have like those blue stars. So where are those blue stars coming from? So the theory is that when you have a lot of stars, or a large collection of stars, there's probably going to be stellar collision. And it's believed that those blue stars are the product of stellar collision. Two stars colliding.
Yeah, it's basically creating like new young stars. It's amazing. That's such a cool thing. Can I tell a cool story about globular clusters that I learned recently?
Sure, go for it.
Okay, so there's been recent. Okay, so one of the things that we always used to talk about in these presentations was the uncertainty around habitability in globular clusters. And I was reading some research recently that said, actually, if you could get life, a civilization did form inside of a globular cluster, it might be one of the best places to have an interstellar civilization, because a lot of the things that we'd worry about having an interstellar civilization would be limited in a globular cluster, like the distance of travel time between stars. Like here, if we even really fast spaceships within like the diffuse parts of our galaxy, travel time between parts of like other stars could be like centuries or millennia. But in a globular cluster, because the stars are so close together, it might be only like a few years rather than hundreds or thousands of years. And interstellar communication between the stars could be done in like a matter of weeks or months rather than years or centuries at the speed of light. So basically, if a civilization could exist in a globular cluster, they'd be like virtually like have unlimited resources and maybe be like basically like eternal. So it's kind of amazing. It was some interesting research. It also said that like even if you have rogue planets floating around inside the cluster that aren't attached to one star system, there's so much ambient energy inside the cluster because the stars are so close together that the planet might still get enough warmth to survive, even if it's just floating around loosely in the cluster. It's amazing. I was like, oh, I'd never thought of that before. It's pretty incredible stuff.
Well, hearing you say that, now that got me thinking about a scary thought. Because when I was talking about like the stellar collision, so those stars, because they're all coming closer towards that center. So depending where you are, we might actually experience stellar collision.
Yeah, and that might be an issue. Yeah, you might not like that.
That'd be scary. So I'm assuming those civilizations, they die off quickly, just like the blue stars.
They might, yeah. If you're on stars that collide with each other, yeah, that might be a bad thing. Yeah, like this is amazing. Yeah, the visual acuity is so much better with this shroud on. I'm so glad that it feels like we have our old telescope back, which is amazing.
I would assume if there was a civilization there, then you would probably, I would think you would always experience with the stars a blue shift. So we usually experience red shift with the stars or galaxies because the universe is expanding. But if you are living inside that globular cluster or any kind of cluster, you'll see blue shifts.
Yeah, I'd probably see stars coming toward you. Yeah, actually, and Dr. Wu pointed out, which is true, it was in the research as well, that one of the problems, though, is that all the stars being so close together, we don't know if it disrupts planetary formation. So if you remember, planets start as like a loose cloud of material orbiting around a star. And if you have stars that are passing near each other, they might pull apart those stellar disks. So as of right now, we actually don't have any evidence of planets existing in globular clusters. That isn't necessarily because we haven't found them, but the methods that we use to find planets around other stars are not as useful when it comes to globular clusters. So there may be planets in there. We don't know. If there are, then they might have access to like a lot of other stars and resources to travel around in space. So this got my imagination firing that maybe maybe we should be looking at maybe at every one of the 150 globular clusters orbiting the galaxy, there's like people living there, because wouldn't that be neat? All right.
And they would not experience even. I think somebody mentioned that they think that if there were civilization within the globular cluster, they would not experience nighttime. They will have day all day.
Yeah, it would be. There's so much ambient light that it's hard to see nighttime. Yeah, exactly. All right.
They will don't see the stars. Actually, just thinking about a scary. Not scary. I'm talking about imagination. For me, whenever I see this globular cluster, I see some sort of a different shape.
Yeah, you were saying that. Yeah.
Last time I saw a spider, I don't know what. This time I don't see the spider. I see a beetle.
That's kind of like a beetle.
Like it's like you see those little legs coming out, and then in the center is the body.
Like a scarab almost or something.
Does that happen to you? Like every time you see an object in the night sky, you see something different. It's not the same.
Almost like a cloud. Yeah, I found that sometimes with like the Orion Nebula when I've been checking it out. I've moved us over to the M24 small Sagittarius star cloud.
We're already leaving the station.
Yeah, we're heading out from the globular cluster.
Nice. So we're going into a star cloud, which is it's kind of like between a globular cluster and an open cluster, but it's not a cluster. It's a star cloud. Which one is called? Oh, M24 Sagittarius. Nice. So this is like going towards so most of our targets are going towards that region. It's like the center of the galaxy, which is very cool. This star is that star cloud is about 600 years wide when we see it through the window. And the depth of it is about 10 to 16,000 light years, which is very cool. But that cloud itself is about 10,000 light years away. And Messier himself actually also cataloged that object. Our famous French astronomer.
Yeah, he's responsible for most of our starry nights are courtesy of Charles Messier, really.
And he didn't have the intention to, find those objects.
That's right. Thank you, Charles Messier.
I know. Thank you. Yet other intentions. Very comet related.
There you go.
I don't think I've seen it before, actually, now I think about it.
Yeah, it's pretty neat. So yeah, as Zena was saying, we actually have a lot of targets kind of toward the center of the galaxy. So if we look on SkyX here, the constellation of Sagittarius is kind of toward the center of the galaxy. So we're looking near the horizon. If you could see the Milky Way, it kind of heads off in this direction. So this is the core of the galaxy here where we're pointed. And a lot of the nebula and that we'll be looking at tonight too are also in this direction. This star cloud is actually visible through a hole basically in the interstellar gas toward the center of the galaxy, because one of the problems in imaging the center of the galaxy is that we're looking through all the dust. So all the arms of the plane of the galaxy are in this direction. And so it's very dusty. Trying to image the center of the galaxy is actually quite hard. And seeing stars toward the center of the galaxy is also quite hard. But the Sagittarius star cloud is kind of like it's visible through a hole in some of the nebula that we're about to look at as well. And so we can kind of see this stream of stars that are toward the middle of the galaxy that otherwise we can't see, which is kind of neat.
Nice. I can totally see it. Like it's like I can see the in-between thing that we were talking about. Like it's somewhat like a globular cluster, but it's not. But it's also like an open cluster, but it's really not.
Yeah, so it's like very loosely associated stream of stars, a star cloud.
Star cloud, exactly. And I like how you can also distinguish the colors.
All right, let's see if we can pop it up a bit more here. There we go. Yeah.
Look at that. Do you see this line of stars in there?
Yeah, it's pretty
Like
cool.
in the middle, it's like to me it looks like a butterfly or like a bow. Do you see the bow?
Yeah, it does look like that actually. Yeah, that's true. So not a cluster, not an association, a star cloud.
Star cloud. So are they gravitating towards each other? Or not really? It's just visual.
Yeah, visually they're spread out so far apart that they really aren't they're kind of more swept up in the spin of the rotation of the galaxy than they are kind of connected to one another. But we're kind of seeing them through a hole this is like a kind of a way to introduce what we're moving on to is some of the nebula. But this cloud of stars toward the center of the galaxy are visible between the Omega, Lagoon, and Trivet Nebulas, which we'll all be looking at later. And speaking of nebulae, I guess it's probably dark enough now that we can actually maybe jump into some of them. So if you want, Zena, we can jump to the Dumbbell Nebula if you want to start checking out nebula.
Let's do that.
All right, let's do it.
Let's get us to the Dumbbell. Dumbbell, yeah. So Dumbbell is, I think, probably one of the most popular nebula, or as. Still don't know. Are we going with nebulas? Nebulae?
Nebulae.
Nebulae. There you go. All of the above.
All the above.
Yeah. So it's probably a lot of our regulars have seen it, but I'm kind of excited with now we get to see it better. I hope we can at least see the colors of it. So Dumbbell Nebula is it's a planetary type of nebula. So for those of you who don't know what a planetary nebula is, it's a star dying. So with low mass stars, when they go through a red giant, and then after the red giant, they would go through a planetary nebula. So that's when the star just sheds all of its gas and dust, and so it would end up or becoming a white dwarf. So that's the fate for low mass stars. So that's what a Dumbbell Nebula. So the Dumbbell Nebula, you'll see that in the middle, or in the center of the nebula, you'll see there is our white dwarf. So that means the star originally was a low mass star, possibly like our sun. So our sun is considered a low mass star, and it will become a red giant, and then after a giant, it will go through a planetary nebula and then turn into a white dwarf. And one of the other things is the reason why they call it planetary is because when Charles saw it, so this Dumbbell Nebula was the first one he found of all the nebulae, all of the above. He described it as plant looking because they are round, so they do look like, I guess they look like planets to him. So that's why he called them planetary, even though it's confusing when I learned about it the first time. Why can't they just call it Death Nebula or Star Dying Nebula?
Yeah, I guess we before I guess we knew what it actually was, then yeah, it would be, we're like, we don't know what this is. It looks like, I think one of the quotes from one of the French astronomers that saw it was that it was like like a fading planet. I think it was between that and the Ring Nebula, that when people were looking at the Ring Nebula as well, that it was like that it looked like a fading planet, which is where the term planetary nebula came from. And then we just never updated it. We're like, the name stuck, it's fine. It's one of the things about astronomy. I don't know if we're really good at naming things in astronomy. I was thinking about like this in the future, that when we're talking about the galaxy collisions and the fact that the Milky Way and Andromeda are going to collide with one another, and the best name that we've come up with so far for what that future galaxy is going to be is Milkomeda. And I was like, I guess we have 4 billion years to come up with a better name than that for that galaxy.
If we exist, we're probably going to be evolving into something completely that we're not even going to comprehend what we are going to be. So that's what it feels like. So yeah, this nebula is actually one of the brightest objects in our northern hemisphere. So I think it's a good object or target to use with binoculars. This object itself is 1,227 light years away from Earth. And what I really like this nebula or this target in particular, it's because it's the one that really got me thinking about this aspect of time with respect to space. It made me realize that everything we see in space, we're actually looking into the past.
Oh yeah, for sure.
Never the present. So we're looking. So space is like a time machine that takes you to the past, of course. So when we look at this nebula, we're looking at it, how it looked like 1,227 years ago. So I'm assuming if we were to look at it if we were to look at it at its present state, I would assume that maybe the gases probably are shedding, like maybe they're further away from the white dwarf in the middle, or maybe that all of it is completely gone and they only left with the white dwarf. Who knows? What do you think?
Yeah, I think I agree with you. I think one of the cool things about space is that we look at the stars, and from our perspective as humans, the stars look fixed and permanent. But when we're able to look into space and see that space actually changes, but just on scales that are so much larger than us, you realize that you're actually a part of this grand story. And I think that's humbling. So I agree with you there on that. That's one of the reasons why I love looking at space. It's like it's realizing that the sky is full of stories and that we're a part of them in a small way, and that we get to know them. Oh, there we go. Now we're getting. I had to play with the colors there a little bit, but now I got it to pop there.
That's the history of space.
I was also thinking that, like, so this, I'm getting a bit philosophical, but I was talking with a friend of mine who's a writer, and her and I were having a conversation, and we're like, okay, maybe the whole point of life is to turn time into language. Mm-hmm. Because if life's not around to do that, if life's not around to do what we're doing right now, is to take this like image of time and talk about it in terms of what it is, that life itself, like one of the functions of life is to translate time as a dimension into like language. I think that's amazing. I think that's a cool thing that we get to do as living creatures on a planet in the universe.
Are you gonna write that in one of your articles, space articles?
Sure, why not? I should. Yeah, I can. We don't usually get that philosophical in our space articles, but we should. Okay, here we go. Yeah, now we're getting it. Look at this. I just had to boost my...
We're seeing the red, we're seeing the blue, which is kind of cool because the colors in space, they like when you see the nebulas, it tells you, it kind of reflects its composition, its chemical composition. So with red when it actually reflects hydrogen and helium. So when they are ionized and under high pressure, they're red. Hydrogen is red. So whenever you see hydrogen in a nebula, whenever you see the color red in a nebula, it's hydrogen.
Yeah.
And it makes sense. You see it's on the outside of the nebula because that's probably because the stars will consume hydrogen first. So it makes sense why you tend to see the red color on the outside of the nebula. And then the inside, it's more bluish, and bluish turns out it reflects oxygen.
Yeah, there you go. Oh, all right, come back. A little bit too much noise. Actually, so cool backstory. The first time I ever went astrophotographying out on an evening was with Dr. Howard Trottier, founder of the Trottier Observatory, and it was imaging the Dumbbell Nebula with his like a smaller telescope that he had, but it's where the observatory is now. So like before the observatory was set up, wow. Dr. Trottier was like, hey, do you want to come like imaging with me? And I was like, yeah. So we basically sat out till like 4 o'clock in the morning imaging the dumbbell in where the planetarium is now. And he was telling me like his plans to break ground on the planetarium and what he hoped to build there one day and like how excited he was for it. And now here we are doing these shows at that planetarium. I also remember on the way home, like I walked into a really big bear on SFU campus, and that was the end of my evening where I thought I'd get eaten by a bear. But thankfully I didn't. That's my story.
Oh no, they don't eat people.
No, thankfully. Yeah, they're like giant raccoons more than anything. Yeah. All right, let's move on. What's next?
We have let's check out another nebula. Let's go to how about Lagoon?
I think we want it. I had the Ring Nebula in here. Do you want to do that next, or we want to skip it?
Oh no, let's do Ring. Yeah,
Ring. Okay.
So I just thought because we're in that area. I don't know why I keep thinking. Is the Ring in that area?
Yeah, it is. I figured what we'll do is we can do the 2 dead nebula star nebulas, and then we'll do the birthing star nebulas. So
good idea. Good idea. Oh, Ring is beautiful. I like it. It's one of my favorites. Like you see, the colors are very, very obvious.
All right, here we go. I haven't really talked about my photo processing that I'm doing here. while we're on. So for those of you who are new, we're doing a process called stacking. So if you look down, I think, can you see that part of what I'm imaging? I think you can. So down here we have a number, and it says the number of frames that have been stacked for each of our pictures. So each one of the images that we're exposing is 20 seconds long. So imagine like you're taking a picture with your camera, normally on the ground on Earth, because everything is bright. You just image it really quickly, fraction of a second, and it's done. But in space, we're imaging photons that have been traveling for thousands or even millions of years, and they're very faint by the time they reach us, and we're not collecting many of them from the object. So we have to leave our camera open for a very long time. You don't want to leave it open too long, though, because you might get errors in tracking your object, and it might get blurry, or something could fly through, like a satellite. Once I was photobombed by the International Space Station when I was trying to image something. And so what happens is we take individual images, in this case 20 seconds long each, and then the computer layers them on top of one another. And each one of them adds more information and more data, and also reduces the amount of noise and kind of graininess that's in the picture. So we do like quick imaging, but for each of these objects that we're seeing, so enough that you can see them more so than you'd be able to with your own eye. But really, when you do a fully processed image, when you see something from like the Hubble Space Telescope or from our own telescope, we're talking about hours and hours of exposure time. So Zena, you've imaged some stuff with the observatory. Like, how long have you spent like on an evening just doing imaging?
Oh, well, it's usually it's probably I usually go from sunset and to sunrise because I did when the observatory was built. I was doing my master's. I just started, like, literally the year that they opened the observatory is the year I started my master's.
Okay, cool.
So
Yeah.
Your master's, at least in science, you're practically living in the lab you're in.
Yeah.
Maybe just for me. So a lot of the time, yeah, I did spend, like, whenever Howard needed something to do imaging, he just calls me and say, "Can you go do this?" So when I put, like, sometimes I have experiments where I have to wait many hours before they're done. So in that waiting period, I go to the observatory.
Yeah, for sure.
I was able to be productive and using my time efficiently in both the lab and the observatory. So yeah, it's usually how, like, the way it was, like, sunset is probably you start at sunset, you do your flats, and then you try to go as late as possible.
Yeah, get as much exposure time as you can before like sunrise, right?
Yeah.
Yeah.
But I the time when I actually stayed till 4 a.m. I think the latest I stayed till 4 a.m. Not a joke.
Oh yeah, no, for sure. Yeah, that was pretty common when we were doing imaging, and so yeah, and that's just the beginning, right? Is collecting all the data, and then afterwards is doing processing on all the data, which we're doing quickly here, kind of adjusting some of our levels and on the screen here to cut out things like more of the background light and to bring out the color. So we use a special software to do that, and it's called PixInsight. We also use a little bit of Photoshop as well to touch up some of the images. So yeah, so it's like any space picture you see, whether it's from our telescope or any other telescope, it's not just a matter of taking a quick picture of something in space. It's actually quite a complicated process. But as a result, we're able to get these incredible images from across, the galaxy or across the universe, which is pretty cool. So, sorry, go ahead.
Oh no, this is so beautiful. Like, you can see how the red, it's more pronounced, how it's around, like, it's on the outer side, and then you see how it gets more and more blue. So it's the same thing. You have hydrogen on the outside, helium, and then you go to oxygen.
Yeah, totally. I might even be able to zoom in on this one a little bit more. Let's go.
And you can see even the central star, the white dwarf. That's the fate of a star like our sun.
Yeah, so the burned out core of the center of a nebula like this, a white. So these planetary nebula are not the deaths of massive stars. So massive stars explode and become supernova remnants, which is actually the next target we're going to be looking at, is the remnant of a supernova. So these are lower mass stars like ours. So our sun will look probably something similar to this or Dumbbell in the future if someone's looking at us in a few billion years. And yeah, that central point here, this is the white dwarf, or the exposed core that's left over from the nebula. So cool thing about these white dwarfs, we're finding them that in all different sizes. We used to always say that they were about the size of the Earth, so planetary size. But recently a white dwarf was found that's kind of on the verge between a white dwarf and would be, I guess, considered almost like a pulsar or a neutron star, which is a much more compact object. And it's only about the size of the moon. So we're finding these objects that are quite tiny. Now, theoretically speaking, these objects will eventually evolve into something else called a black dwarf. So a white dwarf is the core of a star that has died. It is no longer producing more energy. It is just radiating off its waste heat into space, like the embers of a fire. So there's no longer a flame, but there are the embers that are left over, and that's what the white dwarf is. Now, it takes so long for one of these things to cool down into what is known as a black dwarf that black dwarfs are still theoretical in the universe. So no white dwarf that has ever yet formed in space has ever fully cooled down yet. The universe isn't actually old enough for that to have happened yet. So you think about that, like the universe actually isn't old enough for any one like low mass star to have ever fully cooled off, which is kind of astonishing when you think about it.
Yeah. So white dwarf, they're just made. It's just so the core of a low mass star is just gonna be the carbon. So when it gets to the carbon, that's when it becomes a white dwarf. That's why they say white dwarf are like diamonds in the sky.
Diamonds in the sky.
Look at all these diamonds. I joked with Abby the other day. I said, you know what? When it's a way to propose to you, they should actually propose you with a white dwarf. They shouldn't call it a diamond.
There we go. Really got to brighten it up there. Although that would be a very heavy ring.
I know.
Yeah. Oh, you really got it to pop now. This is great. I am so glad that we installed the shroud on the telescope. It's made me so happy that we can see these objects again. This is so cool.
It looks very similar to how we would see it with, like when we do it with the filters, the 3 filters.
Yes, yeah. Yeah, definitely. So yeah, our primary camera uses 3 separate filters to image instead of just like visible light through one camera. And there's a reason for that because, without spending too much time getting technical, but when you take a picture with your camera might be rated to like say 10 megapixels, but that's actually not really true because each of the pixels, there's a cluster of 4 pixels on your camera. 1 is red, 1 is blue, and 2 are green. So you're really only giving 1/4 of the full resolution on a color camera. So when we're doing imaging with our main camera, you're using all the resolution, but it's monochrome. So the camera doesn't care about color. It just takes all the light and it puts it on the whole sensor at once. And then what happens is you flip a filter on the front of the camera so that only red light is getting through, and then only green, and then only blue. And then you add them all together, and then you get your picture. All right, let's move on to the next target.
So you said you were photobombed by a satellite?
By the International Space Station once. I have a picture of it somewhere.
By a crow.
Oh, what's that? Sorry?
I'm doing as a, like, I'm just kidding. No, it's not doing like, yeah.
It was like, yo, peace, zip right
Okay.
through your picture. I have it
No.
somewhere.
Well, actually, did you hear like a crow one time enter the observatory?
Oh, that doesn't surprise me.
No? Yeah.
I'll find it later. Yeah, but I
don't know.
have a picture of it. But yeah, the crows are always sitting on top of the observatory because it's warm.
Oh, that makes sense. And there's no one there. But there's no food. Nobody eats it.
Yeah.
I think they go for food. All right.
All
Should
right.
we go?
We're going to move to the Veil Nebula now.
Nice. Yeah, I
Let's
think our
see.
night is going to be all about nebulas. But we still want to get to Saturn at some point.
All right.
I think I imaged the Veils a couple of years ago. You know that time when we used to come in person?
Yeah, and to actually sit down in the chair and like see the telescope move around and stuff.
And there's like 3 of us. There's no social distancing. Remember those days when there were no social distancing?
I know. I'm very glad that finally like people are getting vaccinated. Science is trying to keep us safe. And so hopefully those days come back again. You might have noticed an error message pop up here for a second. It said the dome was like a command is already in process. So what had happened is the dome on its own, it shifts periodically to keep track with the telescope as it's moving. And it happens very infrequently. So every once in a while it adjusts and it'll move left or right. And if you happen to give a command to the telescope to move in another direction while the dome is adjusting, it gets mad at you. It's like, I was already doing something. Why are you telling me to do something else? But if I reconnect here to the dome, it should find its way over. Sometimes it actually has moved and the software just hasn't updated. So it turns out we're actually looking at something. All right, here we go.
No Veil.
Yeah, I'm excited for the next like cluster of nebulae. We're really now getting into the stuff that we couldn't see before just because of the light pollution. So we're really starting to see here the cool stuff that we weren't able to see before simply because of all the light that was coming into the telescope. Oh, I seem to have lost one of my... Did I lose a camera in the stream somewhere? Oh, we did. Sorry, I didn't notice that till now. Where is it? I said, no, just noticed in the live stream that one of our cameras seems to have gone down. Or it's the internal one. Let's see if I can bring it back.
Oh, yeah, it's bright.
I don't know why that happened.
Remember those days when
there we go.
When we were in the observatory imaging late at night, past midnight? We would order pizza. We would have to make sure we order pizza before 11 because they all closed.
Because they closed down, yeah. You'd like make a walk over to the Pizza Hut on campus.
Yep.
That was like one of the best things.
To watch. We have to put, because we can't just like when we sit down, we have the imaging that's doing its thing, and then we have something to watch on the side. Yeah,
usually put on episodes of Star Trek. Because I was like, well, what else are you going to watch while the telescope's just sitting there imaging? So yeah, basically the telescope will continue to track. You set up a program where you tell the number of exposures it wants to do on an object, and you just let it run, and we would just sit there. You check it every once in a while to make sure it's still on target, and it does most of the work on its own. And so we would sit there and do spacey things, like talk about space, watch Star Trek. I miss those days. But I'm glad that we get to spend something we couldn't do before as a result of the pandemic. Is connect like this with all of you online. So that's really cool because it's something we always wanted to be able to do, was to stick a camera on the telescope and do these kinds of live streams. And I'm glad now that we can do that with all of you, and that the impetus to do so, to finally get that working, was because of the pandemic.
Yeah, I agree. I totally agree with you.
All right, it is in there. I can kind of see it.
You probably want to make it darker.
Yeah, I'm going to try to boost the exposure a wee bit.
Oh yeah, it's showing now.
Yeah.
Kind of. Somewhat. It's like on the side. Yeah.
I did this one. In fairness, I did test this target pretty late last night after it was probably a wee bit darker. But let's see if I can get even a little bit of it. If it's not too dramatic, we'll go on to the next ones because they are more exciting than this one is. I mean, this is pretty cool, but...
Yeah, it looks... I don't know. So this is still in the same direction, I believe.
Yeah, so this one's a bit wispy. So I'll chat about it a bit, even if I can't get it to come up too much. But the Veil Nebula is a supernova remnant. So we've been showing ways that that stars die. Two less violent were Ring and Dumbbell. So those are the deaths of low-mass stars. This was the death of a massive star. So this star exploded probably about 10 to 20,000 years ago. And it's part of a giant structure in the sky called the Cygnus Loop. And the Eastern Veil Nebula is a portion of that loop. And it's actually the remnant. So the remnant of this explosion is 6 times bigger than the full moon in the night sky. It's actually enormous. But we image and dissect parts of, or we have segmented parts of the nebula into different categories that we call like the Eastern Veil, Western Veil, that make up part of this loop of the galaxy, or of the explosion. Now, the thing about supernova remnants is that the star is blown apart so entirely and expands so quickly that we actually, as big as they are sometimes difficult to detect because the structures become so large that they become lost in the background structures of the galaxy itself. So most supernova remnants are only visible for about 100,000 years, and then they've become so big that they are now unrecognizable from just the rest of the galaxy. And so they kind of fade away on us. But this one is still defined enough that we can actually see it.
They're turning into ghosts.
Yeah, that's a great way to describe them. They're basically turning into ghosts. So this one's not coming up quite as clearly as I hoped it would, but you can make it out there in there a little bit. So you can kind of see this hazy, wispy cloud of it in here. If I can bring the blue down, that might help.
Because I think this one's cool. You see all three different types of, like, there's different types of nebula. Is that this one that has it, the Veil?
It's the Trivet Nebula we're coming up to is going to have that, which is pretty cool because it's like 3 different types of nebulae in one. This one's not turning out quite as well, so we can probably skip over this one and head to another because it's still there. We can definitely see it. This is one of the wispier nebulas, so the fact that we can see it at all is actually pretty cool because this is one of those things that before we'd put the shroud on would be basically invisible. So it does. It's getting clearer because we're putting more and more stack into it as well, which is great. But some of the other nebula are, I think, a bit more dramatic than this, so we might be able to get more out of them. I'll bring up the black a bit more and see what happens. Yeah, it's almost too much. We might be losing it. But yeah, it's definitely there. So that is pretty cool. So I am excited about that. There it is. All right. Okay, so we're going to move on to one of the most famous of the nebules. And this is one that basically made the Hubble Space Telescope famous, and it is the Eagle Nebula. And we have not looked at the Eagle Nebula for a long time. So the fact that when we checked this out recently after the shroud had been put on, and I was like, oh, you could see it, was very exciting. So that's where we're going to head to next.
Cool.
Yeah.
Can we see the pillars?
Yes, we can. And that's one of the cool reasons why I want to check it out.
And it's actually even studied, this one. Like of birth star, like how stars are born. They looked into Eagle, or that pillar of creation.
Yeah. Jennifer brought up Night of the Triffids, which is this kind of obscure Wyndham article, I think, or book. It was also written. He also wrote The Chrysalids, one of those books I had to read back in high school. And Day of the Triffids was about these walking plants that came to life and like tried to eat people and stuff. It was funny. Actually, and I'm glad you brought that up, Jennifer, because that was the first thing I thought of when I looked up Trivet as well. Anyways, you'll notice now we're finally moving over here, which is toward the center heart part of the galaxy where there's a lot of cool stuff going on, including the star forming of the Eagle Nebula, the Trivet Nebula, and the Swan Nebula, which we're going to be looking at now. So I'll begin our trio by heading over to the Eagle Nebula, and we'll go from there.
Sweet. I want to see if it really looks like an eagle.
That's a good question, actually. I don't know what part of it is supposed to be the eagle part, I'll admit. I know the pillars, and there's a spire, and some other cool structures inside, but I don't know which part is actually supposed to be the eagle. Maybe Joanna can point it out. All right, here we go.
Well, we'll see if I actually do see it, because like I mentioned, I see different things every time.
That's right, yeah.
No, like there's nothing happened to the nebula itself. Or maybe it did. You never know. Maybe something is happening to it. That every time we see it, it looks different.
Mm-hmm.
Like further into the past. If you had it, what's your favorite nebula? If you had to choose a nebula where you want to live in it, to have a civilization in the nebula.
Yeah, I guess, well, probably in most nebula, the stars and stuff are so young, there's probably not anyone living in them yet. But if I had to just visit a nebula.
No, not in Mass Effect.
Oh, that's true. Yeah, in the video games they're robotic. I think they've settled though, is what happened. They've been like colonized.
I don't know. Forgot what they were called.
The Geth, the robots, those ones.
Yeah, but they had a name. They're very specific. They look like aliens. Well, no, they are all aliens. What am I saying? They're all aliens.
The alien robots, yeah. All right, here we go. So we're on Eagle. And... oh, yeah, okay, I can make out. I'm pretty sure the pillars are over here, so...
The pillars itself are the Eagle. Yeah. So apparently it's the pillars itself
are considered the Eagle. Yeah, that makes sense.
Well, I like the Horsehead Nebula.
Oh yeah, Horsehead is beautiful. Yeah, it's one of those targets we'll have to get back to in the winter time.
Yeah, I don't know if we've ever initially. I don't think we were able to see it or see it clearly much. Sure.
So the pillars are here. You might start being able to just make them out because they're up here on the right. I'll keep processing, and as we're exposing, they should come out even clearer. Dr. Wu says, Hubble's first image of the Eagle Nebula, the Pillars of Creation, was one of the things that inspired me to study astronomy. Yeah. I think that picture was one of the things that like blew away so many people. It definitely demonstrated the power of the Hubble Space Telescope. And I have that picture. So when we're done processing, we'll show what a Hubble image looks like. Now, normally I wouldn't want to be upstaged by another telescope, but if you're going to be upstaged by another telescope, Hubble's probably the one to be upstaged by. So that's probably okay.
That's funny. So is that an open cluster? Is that what's shining the Eagle Nebula?
There is, yes. So there are a number of star clusters that are forming within the Eagle Nebula. So as this is becoming clearer and clearer, so you can see it over here, it's starting to finally take shape. The Eagle Nebula is what's known as an emission nebula. So there are several different types of nebula, and emission nebulas are nebulas where the gas themselves are so excited, it's so energized by the stars that are forming within that they are themselves emitting energy. And so they begin to glow. In this case, there's a lot of kind of red glow because hydrogen tends to glow in kind of a reddish color. And the pillars here that you're seeing that are taking shape in the upper left here are known as the Pillars of Creation. So these are a star-forming region that were also imaged by the Hubble Space Telescope. And most of these filaments that are reaching out into the get them a little bit clearer here. I start talking and then I stop processing. When we get out into the edge here, these pillars that are taking shape, they're about 10 light years long each. So they're really big. Like these are giant structures that are inside of the nebula. I'm going to zoom in a little bit on them here.
Somebody says they look like aliens.
Yeah, a little bit, yeah. All right, let's see if we can get them to pop a bit more. Might be zoomed in.
Oh, yeah. Oh, wow. They totally do. Nice.
There we go. And a little bit too much green. Let's bring the green down. There we go. Now we're really starting to see them.
Look at that. Wow, big difference before and after. It's called shroud. That thing they
The
covered.
shroud, yeah.
Not like a cloth.
There we go. We're really starting to see them now come up. Oh yeah, am I out of frame with the sharp cap window? Actually, you're kind of seeing what I'm seeing right now, so I'm sort of just zoomed in. Let me zoom back a bit more. All right, I might have to adjust here a bit.
So is the green that's light pollution? I'm assuming the green at the bottom.
Just realized I was a little bit off in where I've been centering my window. Sorry about that, everyone. So I've lowered it down a little bit more so you can see a bit more of what I'm seeing. All right, there we go. There we go. Okay. Oh, too much. Too much again. There we go. One of the downsides of doing this remotely is there is a little bit of lag. So sometimes when I'm adjusting, it's not always following what I want it to be doing right away. Yeah, so in addition to, while we're looking at this, the Eagle Nebula is about 5,700 light years away, and the star-forming region contains about 8,000 stars that are being created inside of the whole thing. We zoom back a bit, you'll get a little bit more of what the whole thing sort of looks like. There we go. You can see that star pillars of creation. I can zoom,
nice.
Cut out some more of this light
stars
pollution.
are being born. Where the protostars.
A little bit too much red still. So cut that back. Let's do this.
I'm just noticing more green. Like, do you see the bottom of the image? Is that light pollution?
Yeah, I think that's a little bit of glow that's still coming from the campus because the target is still pretty low to the horizon, so we're getting some of the glow from the ground here on this one. But yeah, look at that. You can definitely make out the pillars there, which is really cool. So there we go, pillars of creation. Now, again, didn't say I wanted to be upstaged by anybody, but here is what the Hubble Space Telescope image of the pillars of creation look like. So Hubble did 2 photos. There's the original one. This is the 20th anniversary version of the picture, because the pillars of creation were updated in a subsequent image after the Hubble Space Telescope had been upgraded in higher resolution. So this is what that same region looks like with the Hubble Space Telescope. This is what over $1 billion telescope will be able to do for you in terms of resolution. The other cool thing is that Hubble can do is that Hubble also has an infrared camera that can see through dust. So we're looking at all the dust and how it's glowing, but it's also able to see through dust as well. And if you look through the dust, then it looks more like this instead. And this is sort of the vision of it through all of that dust, which is pretty cool.
Wow, that is gorgeous.
Yeah, so that way we can study the stars that are being born inside of those clouds using infrared cameras. And the new telescope that's being launched as sort of a successor to Hubble, which is the James Webb Space Telescope, also is primarily going to be seeing in infrared, so it's able to look into other parts of the universe that we haven't been able to see before as a result, which is cool. All right, on to the next one. Zena, you're up for this one. Swan Nebula.
Oh, Swan. That's a pretty one. Oh, okay, we're doing the birds one now.
Yeah, I guess so. Yeah, I didn't think of that. You're right.
The birds. Okay, it's like we're having a bird theme here. Okay, yeah, Swan. So this one, it's got its name from the shape. I guess it looks like a swan. It looks like a bird. It has different names like Checkmark Nebula, Horseshoe, not Horsehead, Horseshoe Nebula, and Charles wasn't the one who discovered it, but he cataloged it. So he gave it an M. So he cataloged it in 1764. It's in the constellation Sagittarius, and this one is about 6,000 light years away from Earth. So the cool thing about this nebula is that when we're gonna see how red/pink it is, and it gets that color. It's because there is an open cluster in it, and that's what brings the color of that pink nebulosity, which is very, very cool. And it's actually like that. I think that nebula, that open cluster in this nebula is one of the youngest one in the universe. It's about 1 million years ago. Oh, like at the age of 1 million, which is very cool.
Isn't it amazing to think that like 1 million years is young?
I know, right?
Yeah.
And you have to be like 13.7 billion, then you're considered old.
Yeah, it's old. Yeah, then you're old, right? If you're as old as space, then I guess you're pretty old.
There you go. Yeah, that is actually very, very, very interesting and mind-blowing at the same time that 1 million in space is actually young.
Yeah, no kidding. All right, let's see what we got here. First of all, we need to bring up our blue. So you notice as they're actually, I don't know if you can see, kind of at the very, okay, you can kind of see the very top now that I've readjusted, but some of the peaks here between the various colors, they don't always come in even, so we're trying to like align them, and that helps to sort of mesh with the colors in the sky and compensate for like a lot of the green and things like that are coming in. So once we align the color channels a bit, they should clear up and look a little bit more like a natural black sky.
Yeah.
There we go.
I don't know if I mentioned, so this is a Starburst Nebula. So it's the place where stars are being born. So if you were to guess the color scheme when it comes to Starburst Nebula, you're probably noticing that they tend to be on the red side, or it always has that red or pink shade. Pink shade. Did I say shape? I meant shade. 50 Shades of Red.
Oh yeah, look at this. Look at the structure in this one. This one is so cool because it looks billowy.
Yeah, I don't see the swan. I see a fish. Last time I saw a submarine. Now I see a fish, Oh my god, I see a fish. I see the eyes in the front.
Oh, too much. Hang on. Lag.
And
I'm playing
then
lag.
all of the. Or then
Actually, that was kind of
maybe
nice.
a whale. I see a whale. Oh yeah, was that you who made the comment last time? Like you Messier would see a comet. Was that you who made that joke?
Yeah, yeah. I know that wasn't me. Someone else did. Yeah, that was hilarious. There was someone who was like, "What do you see it?" And they're like, Messier would see a comet. I was like, that was hilarious.
That was good.
Oh yeah, look at that. That's amazing. All that structure. So again, yeah, all the gaseous, gaseous nebulae. Anyway, so this is all these stars that are forming toward the arms of our galaxy, looking toward the center of our galaxy. So like,
Beautiful.
cool structures. Yeah.
Do you see the fish? Like, you know, if you go to the front of it, you see the eye. It's like the eye of the fish.
Oh yeah, over here.
No, lower.
Oh, here. Wait, is it a star that's
No.
the eye of the fish?
Yeah. This is like the eyes.
Hmm. Kyle agrees with you. He says he sees a fish as well.
Yeah, everyone's seeing like the fish, more like a fish scene, not the bird.
Oh, awesome. It's amazing to think that we started this way, right? Like the giant cloud of dust and gas. That's like us. That's what we were. You know, we were just this floating around in space.
We're made star stuff.
We are made of star stuff. Yeah, absolutely.
Everyone. So when someone tells you you're a superstar, they are very accurate about it.
Yeah, totally.
Everybody is a superstar.
A superstar. Yeah. All right. Well, oh, I can maybe pop this a little bit without it getting too grainy. But yeah, look at all that. Look at all that detail in there. It's amazing.
That
Wow.
I like it. I like how red it is. And you're seeing more of the top. Where are you?
Awesome. All right.
Let's go to the next one.
So you picked this one out. You're like, we should do this one, and you were right because then I checked it last night. And it looked amazing. So the Lagoon Nebula.
Another Starburst Nebula.
Yeah, and that also in the same place, right? So we're looking. All these last couple nebulae are kind of all in the same part of the sky and in the same direction of the galaxy, as you can see again. So we're not moving far from one target to the next. It's so busy toward the core of the galaxy, which is where we don't live. We live more in like the New Westminster of the Milky Way. We're not in the downtown. We're out in like the suburbs.
New West is not that far.
Yeah, I guess not. I guess it's not that far out of the galaxy. I guess we live technically more like the Abbotsford of the galaxy.
Yeah, Abbotsford. That makes some sense. Chilliwack.
Yeah.
To put it into perspective.
To put it in perspective, yeah, where we are.
How empty we are.
That's the telescope capturing us moving. Here we go. Okay.
So Lagoon Nebula is also a starburst. So you're probably already gonna guess that the color is gonna be more on the red, like it's gonna be red shades. And also this is an emission type of nebula, which means the stars are actually ionizing the gases in the nebula, and so or the elements, so that it would give off that red color.
That's right. Yeah.
And this is the kind of nebula that you can see. Apparently, you can see it with the naked eye in a clear night, of course.
Mm-hmm.
Probably not likely in Vancouver, but clear night. Let's put it that way. And this light year, because it's very close, it's like they're in the same area where the other nebulas we were looking at. So this one is like around 6,000 light years away, which is similar to the previous one.
Yeah, because they're kind of all part of the same giant cloud. Like there's one like super cloud basically around them of gas. Yeah. That's, you know, and so all of these regions are all kind of one big giant star forming complex, which is amazing.
I don't think I've ever seen the lagoon with our telescope. So, well, until the one you showed me.
Yeah. So yeah, and when we were thinking about targets, and then it was you, Zena, who's like, because I was picking out a couple, and then you're like, hey, you should check out Lagoon. And as soon as you said it, I was like, hey, that's not a bad idea, because in the past I had seen images of Lagoon and it was so pretty, and I hadn't tested it as a target for so long. Just because it was like, it's another faint nebula. It probably won't show up in the light pollution. But then after your suggestion, like getting a chance to look at it, it was so pretty. So course, now that I've said that, I better sell the image I'm about to process here.
Yeah. No, the one you showed me last night looked really good.
Yeah. Let's see what we got.
Coming out. Very pretty. Lagoon. I wonder what they mean by a lagoon. Not another type of bird, is it?
I think a lagoon is like a creek or swamp, I want to say. Isn't that what it is? There we go. Yeah. Look at that.
Oh, wow. There you go. That's pretty.
Oh.
And you know, we were talking about this. Were you talking about like the not a hurricane, but which one? We talked about like some sort of like, it looks like there's like jets of stars being formed.
Right, yeah. I'm glad you brought that up because I'd forgotten about it. So one of the cool things about the Lagoon Nebula is that it was one of the first places in space where we found something that is now known as a Herbig-Haro object. Herbig-Haro object. And it's basically what happens when forming stars, we call them protostars. So a star before it is fully formed, like a forming kind of like young baby star, it's called a protostar. And as the stars are forming, they're accreting material. So they're pulling in gas from the surrounding cloud. But some of that gas gets accelerated by the young magnetic field that is forming around that star and gets ejected into space and hits the surrounding gas. And this is one of the first places, the Lagoon Nebula, where these objects were discovered, and they've been since imaged by the Hubble Space Telescope. And I have one of the photos, and it's one of the coolest things I've ever seen. I was like, what? So I downloaded the photo so you can see it. So within the Lagoon Nebula is one of those objects, and it is here. That is a legit photo from the Hubble Space Telescope. It looks like some kind of artist rendering or like a computer rendering, but that's what it actually looks like. So this is, look at that. That is the birth cry of a new star that's forming inside of the cloud of gas. So these are the jets coming off the North Pole and Southern Pole of that star in the gas. And this was taken inside of the Lagoon Nebula, which is, it's such a cool picture.
Looks like magic.
Yeah, it does. Yeah. And so, yeah, that's forming. These are one of the things that are forming inside of the Lagoon Nebula.
Is it in the middle of that image? You know, you see like this very bright red in the middle. Is that what it is?
Yeah, so it's like the jets that are coming out from. So that is like the star inside of the gas being like, I'm coming alive, and spraying out inside. And our sun would have had that moment. It's interesting because I also do work at the planetarium where I get to hang out with young kids. And we talked about, as you were saying, Zena, like we were talking about like how looking at objects is kind of like looking at the past. And one of the youth asked me, if you could time travel, what moment in time would you go back to? And I said, the moment the sun started like fusing hydrogen, like the sun was born, the time that our sun became alive. I would want to go see that moment. I think that would be cool.
That's actually a really cool question.
Yeah.
One of you asked that, or did you ask them that?
They asked me. They're like, what point? Where would you go time travel to?
That's so good.
Yeah.
That's a really good question. Like, at what moment in space you want to go back to see? I like that.
Yeah.
I might want to go back to the Big Bang.
The very beginning of everything. Yeah.
Yeah. What happened before the Big Bang?
Time zero, right? I guess we better. I know there's a couple other things we want to look at. So let's jump to the Trivet Nebula because it's really cool too. So it's the last of the group of nebulas that were in this region of the galaxy.
Yeah, Trivet, and then are we gonna have time to do planets?
I think we might be able to squeeze them in. So if we can do this one quickly, because we had some planets we wanted to show you tonight. So this was the last of our other targets. We're gonna do a galaxy, but we'll skip it because it's the galaxy that we wanted to look at was not super clear, even with it's pointed toward the north where there's a lot of light. So we'll do this last nebula, and then we'll do some planets. And then we'll have talked about space.
Yep. Okay. So Trivet Nebula, same area. So this is actually really cool. It has this nebula has 3 types of nebula. So there is what's called emission, and we talked about the emission. Emission is when you have the stars that ionizing the elements to give off that color of the nebula. And there's also Reflection Nebula. So that's when the nebula itself reflecting the colors of another, whatever it is, a neighboring star or a neighboring nebula. It's not its own, like what I mean by reflecting, it's not its own, like the nebula is not giving up its own color, it's reflecting something else, another object color, to put it that way. And we also have, it also has what's called a dark nebula. That's when it's neither reflecting or emitting light. It's dark. And you'll see what I mean.
So a hat trick, 3 in 1, all in one object.
Yep. Very cool. I think we imaged this one. For some reason, I don't have a memory. Like I was one of those people who imaged this nebula, and I have no memory of it. I think when you do so many of them, you don't keep track what you've done.
Oh, have you done? I didn't know that you'd imaged this one on the primary camera.
On the record, it says.
Oh, okay.
Like on the record, like that I imaged it. I was like, oh, I don't even remember.
I know. And sometimes we're going through it. I remember a few times we've had to organize the drive, and there's like terabytes of images in there, and we're like, oh man, we got to process some of these.
Yeah, I've also done apparently what's called the Butterfly Nebula. Have you heard of that?
Oh, it's beautiful. And then sometimes hard to see. I think it's only above the horizon for like short periods of time.
There's even like it's called the little butterfly, something like that. But yeah, let's try to get that trified. Terrific. I like to call it the terrific. The terrific nebula.
All right, got our color down.
Yeah, so this one is interesting. It has like this nebula. I hope we can see it. It's surrounded by a cluster of about, I think, 3,000 young stars. So when I say the word young, you probably can predict the color of those stars. They would be blue. Would have thought blue in space means very, very hot. And
that's right. Yeah, backwards.
Red is cold. It's an oxymoron.
It's starting to show up. Here we go. You can make out the outer cloud here, and you were saying like the dark parts, the dark nebula, are here. Yeah. So they're making out the shape. It's almost like a heart, and you can see it in there.
Yeah, I don't know. Can you make it a little bit darker?
Yeah, should start working on it a bit more here. Should get it to pop. There we go. Starting to come out a bit more.
Oh yeah, and this is a Starburst Nebula. I forgot to mention. So, Starburst means it's a place for star being born. Look at that. Right.
Yeah, as you can see, it's starting to form now in there.
Pretty good. I like it. I think it's sometimes there's nothing we can do when you have those lights, because you're right, it is close to the horizon.
Yeah, this one's close to the horizon, and it is still a bit bright out, so we're going to get a little bit of light pollution.
I hope we can go past the time, because we are at 11:29.
Okay, so we'll do this one, and then we'll jump to at least one planet. I will show one picture though. So the Trivet also has these jets, jets that are coming off young stars, similar to in the Lagoon Nebula, but it's more buried in the clouds, which is kind of cool. So yeah, you can see the dust lanes here from the dark parts of the nebula, as Dr. Wu was pointing out here. I'm also going to show this picture. So this is another really cool picture that Hubble took in the Trivet. So check that out. So this is the jets, those jets that are being accelerated off into space by these young stars. And so there's a star basically inside of that cloud of gas within the Trivet, being like, I'm alive. I'm inside. I'm forming inside of this cloud of gas. And throwing these jets out into space. And that's another one of these beautiful pictures. I was like, wow, that's incredible. And so these things are going on, these stars forming. It almost looks like the head of a snail inside of
oh my
the
God,
Trivet
that's
Nebula.
what I was going to say, I swear.
There, we aligned.
snail.
Head of a snail. There we go. Yeah. So these jets coming off of these young stars being born inside of these clouds, which is pretty amazing. And then what could that be in the future? You know, some civilization maybe come to life. Okay, so we're basically at time. So let's jump to, you know, one target we haven't been able to see for a while. Definitely time to see, and it is a planet, because we've got these planets that are up right now, and we should check them out. And I guess I'm giving it away because you can see me typing in the target, but it is planet Saturn.
Nice. I think Saturn is it's everyone's favorite. Even when I ask the students, when we talk about planets, I ask them, talk about a planet. Pick a planet to ask questions and do a project on. And for some reason, they all do Saturn. It's like, why are you all doing Saturn? It's like, this is our favorite planet. It's like, I better not see you copying off each other. It better be different information.
Ah.
It's like, you would. But yeah, no, Saturn, of course, I think it makes sense that it's everybody's favorite planet because it's the one that has the rings that we can see. Other planets have rings. We just can't see them. They're not visible. But Saturn is the one that's visible to us.
That's right. Yeah.
It gives it that 3D look. Because anything we look in space is more 2D.
Cool? I was gonna say one time, I mentioned that Saturn was my favorite planet with a group of youngsters. And then one of the youth said to me, "Why isn't Earth your favorite planet? We live here." And I was like, actually, that's a good point. So now I say that Saturn is relegated as a close second.
That's true. Fair enough. Well, you might. It's not. I don't know. Like, just when I was reading on Saturn and finding all these cool, fun facts about Saturn. So one thing is that Saturn the density is less than water. So if we were to have a bucket of water that covers Saturn, Saturn would float on water, which is kind of cool.
That's amazing. Yeah, if you had a bathtub that big, I guess.
Theoretically,
yep.
But not physically possible. And 1 year, like if we talk about like years, so one round around the sun with Saturn, so that's 1 year, is about 29 years on Earth.
Wow.
Yeah, I know. And Saturn, the day, because Saturn spins on its axis very fast, so one day on Saturn is 10 hours and 14 minutes on Earth.
Amazing.
Yep. And this is also something cool. So because Saturn has look how our axis, the rotation axis, is tilted. Mm-hmm. So same with Saturn. So that's why because Saturn's also tilted. So that's why Saturn has seasons.
Oh, like cool.
So, but the seasons there spend longer They spend years. So a summer on Saturn is about 8 years. No, maybe 10 years, something like that.
Amazing.
That got me thinking. If I were to pick a season that I want to spend that many years, like 10 years, which one would you pick?
I don't know.
I think I'll go for the spring because I want cherry blossom. I don't mind having cherry blossom for 10 years.
Saturnian cherry blossoms.
Yeah.
Yeah.
But I think that doesn't go well for people who are allergic to pollen. That would suck.
Yeah, especially space pollen. That might be a problem. So, Xena, if I were Tyrannosauruses have very short arms. So I'd imagine that it would be difficult for a Tyrannosaurus to use a telescope. But if a Tyrannosaurus were able to use a telescope and they looked at Saturn, what might they notice about Saturn that might be different?
The rings?
Yeah. Yeah, you were telling me about this, right? That the rings they may have not been around back that long ago.
Oh, have I? Can't remember. But
I
know
we talked.
I know
about
the rings they were part of they were usually because you know how Saturn has many moons. So I think the Saturn at some point they're just part of the reason why they were formed is because the moons collided, and then it formed those rings.
Yeah.
Go ahead.
Yeah, and then you were telling me that they may not be around forever either. Like at some point in the future. I don't know it won't be a dinosaur in the future, but whatever's on Earth in the future, if they're looking up at Saturn, the rings may not be there anymore. So we happen to be apparently in the good time for checking out Saturn and its rings.
Oh yeah, but that's gonna be way into the future. Like so probably sorry, when you said dinosaur, I was thinking before us. That's why I was confused. But I'm thinking our evolved form.
Okay, yeah.
Like our evolved form probably will not see Saturn's ring
Yeah.
because it's potentially gonna disappear because of Saturn's gravity. They're apparently like gravity is pulling all these rings towards it, but it's
Yeah.
a very slow process. So we'll still keep seeing it, but who knows? Maybe our great evolved grandkids will not see it.
Yeah, exactly. Yeah. Cool. Everyone's still really around. So if everyone wants to hang out for a couple more minutes, we'll also check out Jupiter, since that was on our list of targets. If you do need to,
I'll tell you one.
Please, yeah, go ahead. Yeah.
Saturn is that in there, you know how we have rain, like just it's water.
Mm-hmm.
In Saturn, it rains diamonds.
Okay, I heard about this. How does that happen?
So so the lighting on Saturn, it has something to do with the lighting. So the lighting there is way more powerful than the lighting on Earth. It's like almost 10,000 times more powerful.
Wow.
And what happens is that lighting, it's gonna transform methane gas. We have methane too, but on Saturn, it turns into large clouds of hydrocarbons that are impure. But later, when you have a lot of pressure applied to that, it turns into diamonds.
Amazing.
Because that's what diamonds are. They're just hydrocarbons, but diamonds are more the pure form. So that's what it is. So when you have enough pressure, then it's raining diamonds. There should be a song almost.
That's astonishing. It's astonishing to think that you could have lightning zapping clouds in Saturn fusing methane together into hydrocarbons that then get crushed into diamond rain. And that's just like going on Saturn. That's a day on Saturn, everybody. Weather today on Saturn, it's raining diamonds. All right, let's so we'll move on. I know. We'll move on to Jupiter, and then thank you again for everyone for staying around for an extra little bit. After we look at Jupiter, you can actually go out and check these targets out, because Saturn and Jupiter are in the sky right now. You can literally go outside and look at the two of them, kind of in the southeasternish sky. Jupiter is the brightest thing in the sky right now, so you can go out and see it. And then Saturn is kind of beside it in the sky, next brightest point. And here it is.
Jupiter. I think Jupiter was the first planet we imaged with the observatory, like using the planetary camera.
I think that's right, actually. Yeah. Let's zoom back a bit here. Oh, come back.
Jupiter's so large, it could actually be its own star if it was just slightly larger.
Yeah, I think it'd have to be.
I shouldn't say larger, more massive.
More massive, yeah. I think it would have to be a couple times more massive than it is, and then actually, I think it might be quite a bit. But there are stars that are actually smaller than Jupiter, which is cool because they're denser. But you can actually have that. I think it's amazing that the overlap between some of the largest planets and some of the smaller stars like cross over with one another. So it's possible to have red dwarf stars that are tinier than the planet Jupiter, which is pretty amazing.
That is fascinating.
So,
and it's not that much. I don't remember how much, but when I was reading it, like from Jupiter, it's like I'm trying to think like how much more massive does Jupiter have to be in order to be considered a star?
I think it might be a lot. It might be like 10 to 20 times more. Let's come back a bit more. Oh, other direction, Matthew.
Look at them. Beautiful. It is looking more orangey. Is that the forest fire?
It could be, yeah, because where are we right now? We're a bit lower on the horizon, and I think there is a bit of smog at this point in the horizon, so I think it might be obscuring Jupiter a wee bit. But actually, I'm going to move the telescope just a little bit.
We love Jupiter. Actually, Jupiter should be also one of our favorites because Jupiter is our protector. It's our shield.
Yes. Yeah. So
Really, we're
yeah,
not giving much appreciation to Jupiter.
yeah, that's right. So how does Jupiter protect us? How is that a thing?
From its gravity, because it's
Okay,
so
yeah.
massive, Venus has high gravity. So you know that we have the asteroid belt, and we always get the comets that come visit us
Mm-hmm.
every once in a while. So if you have a comet or an asteroid coming towards Earth, it's gonna first get sucked in by Jupiter.
Yeah, and I remember when I was a kid looking up at Jupiter in the mid '90s because there was a comet named Shoemaker-Levy, and it broke into 9 pieces and crashed into Jupiter, and left these like giant marks, like these big black scars on the face of Jupiter. What I do before we wrap up, I'll increase the exposure here. That's going to blow Jupiter out, so it'll be overexposed. But that way we'll be able to see Jupiter's moons, and more clearly.
Yeah. Did you know that the red spot on Jupiter? We all know it's a hurricane, but did you know that it's bigger than the size of the Earth? So you can actually put the Earth in there; it will be sucked in.
I know it's probably not a great place to live, Jupiter, unfortunately. However, because of all the storms and everything else that you're mentioning, but we've just illuminated the 4 Galilean moons that are around Jupiter, and one of them is the moon Europa. And that moon, as we've discovered, probably has about twice as much water as Earth has. And we think that there's a subsurface ocean on that moon. And we are planning a mission to go there. Now, which one of the moons is it? I don't know right now. But here's something cool you can do. If you go to Twitter, and you can look up something called Jupiter Moon POS, which is position. And when you look at the feed, it tells you in using a numerical code. So if you happen to see Jupiter, which you can actually see even with like binoculars or like a half decent DSLR camera, will show you where you can find the moons. You can actually, like, if you boost up the gain or the zoom, even on like a decent DSLR lens, you can see the moons of Jupiter like we're looking right now. And if you look up this Twitter feed, it tells you using these characters which one of the moons is Europa or Callisto, Io, or Ganymede. Now, I think ours might be flipped
Second one.
right now
Yeah, I
because
think
we're
they're
looking at it
flipped.
through a mirror. So yeah, there are the 3 on one side. And yeah, so Io is going to be, or Europa is the one in the middle. So here we go. So this is Europa right there. So it's possible that life has happened on that moon, because if we look at Earth, life began in our oceans. We know that these moons, there's one similar around Saturn called Enceladus that also has a subsurface ocean, and that water is the same chemistry as ocean water on Earth. And the exciting thing about this is, even if we find life on Mars, it's not an absolute guarantee that life has happened somewhere else in space yet, because Mars and Earth have shared material in the past. So it's possible that one seeded life on the other and vice versa. We could actually all be Martian for as far as we know, which is kind of amazing just to think about that. But because Europa is so isolated from the rest of the solar system, if we do find life on a moon like that around another planet, it's direct evidence of a second genesis of life. So then we know for sure that life can spontaneously occur in other parts of the universe. And if you find evidence of that, then there's great chance that you're going to find life somewhere else too. So if it happens, it's like with science, you go, or with space, with life, you count to 1, 2, and then infinity. Because if you have 2 happen in the same solar system, good chance it's happening everywhere.
Wow, that's very cool.
There you go.
So I'm surprised there's no movie based on this. There's always movies with regards to Mars. And there's one about Interstellar.
There is one. It's called Europa Report.
Really?
And it's kind of a horror movie. It's actually sort of scary. It sort of made me sad.
I love horror movies.
Yeah. Oh, you do? You like horror movies?
Yeah.
Oh, then check it out. Europa Report. Go check it out. Yeah, if trying to find life on Europa. They sent a bunch of astronauts out there, and it's actually kind of scary.
All about her and psychological thrillers.
Yeah. There we go.
Not bad. 2013. Okay.
Yeah. I'm really stoked that so many of you are still around for the stream. So thank you for that, for sticking out a little bit late. We may have got a little bit overexcited about how many nebula we could show tonight because the telescope's working properly again. So thank you. Thanks for checking us all out. And and we're excited to have you. Thanks for being here. I don't know what the weather's going to be like in the future, but always keep posted either on Facebook. We send out emails to let everyone know if we're going to be doing streams as well, and on Twitter. So you can follow us in all those places. The channel here, SFU Faculty of Science, so it's also posted here on YouTube, so you'll know as well. Thank you to our moderators tonight. So to Indira, Kyle, and of course Jennifer for being with us. Joanna was here too, so thank you, Dr. Wu, for being a part of it. Zena, thanks for hanging out with me.
My pleasure. Nice. It's always nice to chat about space with you.
Yeah, always. And we'll see everyone later. Remember to keep looking up. And if you're still awake and have some energy, go outside and look at Jupiter and Saturn tonight, because out of all the targets we looked at, well, including the stars, so Antares and accurate, it's a little bit harder to see, but you can go out and see these things for yourself too, even without a telescope. And we'll see